So just to get us started with a little bit of a timely conversation today, we're excited to have you with the Wildfire Commons and talking to you all around case study communities. This has been an effort that we've built since the beginning of the Commons and also has been core to our lab on how we collaborate with practitioners, collaborate with all of the stakeholders, and think about these societal challenges and how we can have real cyber infrastructure built behind it. So my name is Claire Sturm, and I am a project manager and community lead with the Wildfire Commons. And today we have Melissa Floka and Ilkay Altintash, who's going to be talking with us about the case study communities. So getting us started, when we talk about case study communities, we want to think about first, who is the core audience? Within our space, we look at the case study community for practitioners, researchers, technologists, and decision makers that have a priority within the wildfire domain and a clear innovation gap that they're wanting to address. So often these communities are already working together to actively close those gaps using science, data, and technology. And one of the ways that we're looking to approach this is with the Wildfire Commons being able to have a focused area with a learning partner in order to extend the commons to serve that community's need and really fill that gap. When we look at focus areas, we're thinking about innovation. So being able to build, adapt, connect workflows across organizations, learning faster by building with others instead of isolation. And then again, thinking about our partners, learning from them in order to extend the platform with the use of data tools and integrations that we already have within our communities, our ecosystems, and really extending the platform's infrastructure to meet those needs. So the common patterns that we have are thinking about reuse and ability to continue use through the wildfire communities and our practitioner space. So case study communities are their own advancement into missions while shaping the evolution of the Wildfire Commons. So as we work with the case study communities that you're going to hear from today, we want to make sure that we're identifying the use-inspired problem with innovation gaps, thinking about the cyber infrastructure requirements, what data, what level of data it's at, the standards behind that data package, models, if they're physical, AI, and then the workflows, whether they're AI, ML, or a more integrated workflow that we can expand upon. Collaboration through data challenges, like the one that we have ongoing with Shrubwise, and prototyping innovation templates. And so by extending the Wildfire Commons, we're really able to meet the R&D needs of special communities within our innovation landscape and serve their needs for others as well in order to come in and extend and be able to work through their own innovation gap as well. So with that, I will hand it over to Melissa, who's going to take us through the first case study community on 4D fuels.
Thank you, Claire. Good morning, good afternoon, everyone. I will go through today some of the activities that we have completed and are finalizing with our 4D Fuels case study community as an update, but also as food for thought as other people across this network are thinking about potential future case study communities. The 4D Fuels case study community started by identifying the priority area around the need to scale prescribed fire and some of the challenges that come along with scaling these vegetation treatments, where there was a consensus that better data, better models, new approaches to workflows and new tools could help us do this more effectively and more safely with better ecosystem outcomes. And so as we started this work, we looked at the different use-inspired problems out there in the real world, but also at the innovation gaps that people across the community were trying to solve. And so we saw that there were multimodal data, there were 3D data, fuel, fire, smoke models, and that there was a need for next generation tools that were able to help with the planning and implementation of prescribed burns, as well as the ecosystem monitoring post-fire. But there weren't good pathways to connecting the innovation that was out there into tools that people could use in operations. And so a big piece of this early on was identified as the need for AI-ready data sets that could also be used in immersive visualization of that data and of the scientific model outputs for not just scientific purposes, but for the purposes of training, decision-making, and public communication related to prescribed fires. And so this identification of both the real-world problems and opportunities, as well as the innovation gaps where people were actively working, served as the foundation for this case study group's work together. And so yes, and basically we had the focus area here of innovation where there was a lot of initial work happening to move to time-aware fusion of the multimodal data and model outputs for planning and implementation of prescribed fires. And that was definitely the focus area of this group around innovation. But at the same time, the people across the community served as learning partners for the platform itself. All the fire, fuel, and smoke modelers, the land managers, burn planners, burn bosses, AI experts, what did they need the Wildfire Commons to provide to them to have a fruitful area for collaboration and for innovation? And so our case study participants were able to both advance their own work and to shape the evolution of the commons through the case study community's work together. And we did a number of small activities, lots of meetings and interaction along the way. But I think the things that I wanted to highlight here today were some of our initial case study community workshop, and then the follow-up meetings and workshops that came as a result of that. Our two data challenges, so our Fire Ready Forest data challenge and our Shrub-Wise data challenge, that gave us an opportunity to all work together on the commons, and then to involve students and researchers in that work too through the data challenges. Our 40 Fuels site that we put together as a place we could centralize all of the things that we were working on as a group. And then the last bit, which is still pending completion, and that's some publications coming out of this work together, as well as innovation templates that make it easy for others to pick up what this case study group has done and then move forward together. So our data challenge, the first one was on Fire Ready Forest, and this one was really focused, in the next slide, Claire, this one was really focused around essentially how can we take sensed data, how can we take terrestrial LiDAR, aerial LiDAR, when we're characterizing our landscapes where we're implementing prescribed fire through this kind of high resolution data, how can we do species identification on top of those data sets, which is something that practitioners do very well through very time intensive processes out in the real world. And so we were trying to understand through this data challenge if we could complement that ongoing work in the field with approaches that could help at the landscape scale to do species identification on landscapes. And in our second data challenge, which is just getting kicked off and is ongoing right now, so there's plenty of opportunity for people to get involved if they would like to. Here we're really looking at being able to characterize surface fuels and shrub-dominated landscapes where, especially in the Western United States, where shrubs tend to drive a lot of fire behavior, but we have very little data and very limited ability to characterize those surface fuels for fuel modeling and for fire modeling, both before and after fires. And so this particular data challenge is going to ask participants to create machine learning pipelines on top of LiDAR data and satellite imagery that will help us get a better characterization of shrub-dominated ecosystems for fire modeling itself. And then if you haven't already explored the microsite that we set up for this case study community, you can do that at 40fuels.wildfirecommons.org. And there you'll find a catalog, and the catalog has basically lots of the different data and models that people were using throughout the work that we did together. And so some of the examples from our community participants in the next slide include work from partners like Intellimon at USGS, who are providing terrestrial LiDAR data and products, Fast Fuels from the US Forest Service that providing 3D vegetation modeling capabilities, Quickfire and QuickSmoke for fire and smoke modeling, and then web interfaces, including BurnPro 3D, to quickly set up prescribed fire simulations. And so you can explore the catalog entries there yourself, and you can see what's been put together by the community. And if there are things that you know of that we should add here, we would love to have those added as well. And then just to give you a little quick peek into some of the data that you'll find there, there's a dashboard with field data where you'll find data that was collected, tree surveys and destructive sampling, and a wealth of field data collected during the case study community's work together. Also, you'll find visualizations of burn units and fuel and fire models in those burn units. And so we have a selection of places that you can explore across the burn units themselves, where you'll find LiDAR scans, you'll find 3D fuel tiles, you'll find fire simulations. And so this gives you a peek into the kind of workflow that is possible, the workflows that are made possible by the data and models in the catalog. And so here you can see one burn unit with LiDAR scans, Pacific Union College, which is an experimental forest here in California. You'll see that you can look at visualizations of, this is just simply the satellite imagery, but you can also, in the next slide, you can look at the aerial LiDAR on top of that satellite imagery, so you can understand the richness that comes in through those kinds of data sets. And then you can look at 3D fuel models of surface fuels. In the next slide, the mid-story, and in the next slide, the canopy fuels, as well as other data products like land fire, surface fuel loading, and depth that are used as inputs to fire modeling. And then I think, Claire, you'll find a little video on the last slide that just shows one of the many interactive visualizations that are available in this site that show the kind of work that people in this community are doing together. And we can just move somewhat quickly through these slides, but this is additional data visualization, which you can explore, of LiDAR scans, both pre and post burn. This is Big Trees State Park. And then perhaps most interestingly for this group, public workspaces, where you can see the kinds of workflows that are being worked on in the community. And so here there's a couple of different examples. One was from Intellimon, which takes LiDAR data, terrestrial LiDAR data from across the country and provides data products and visualizations. But if you want to dig into the code itself and how these efforts are taking that data and providing data products that help with the fuel and fire modeling, you'll find that detail here. And ultimately, the goal of bringing this case study community together was to enable us to get to that level of detail where we really understood the pain points for the innovators and how we could make sure that the Wildfire Commons as a platform was facilitating their work. And with that, I'll turn it over to İlkay Altuntaş to walk us through our second and just getting started case study on digital twins.
Thanks, Melissa and Claire. And as you heard so far, case study communities are really the means, one of the means in Wildfire Commons to bridge the technical platform and the community and science community to these type of problems that we need to collectively, first of all, understand the needs and innovation gaps, then go about figuring out open approaches to solving them, so we can sort of look at the nuances of science and technology and how it can be applied. So, and the way we do this is, as you heard, is identifying priority domains. And it goes through some conversations, of course, but in our case, it went through our own experiences and communities as well. So the first one, as you heard, was the prescribed fire. The second one was our more than a decade-long work in operational decision intelligence, and especially this dynamic integration of data and models to provide those intelligence and learn in real time. So as you know, a lot of, or some of you are new to this community and starting to integrate into it as innovators. Modeling of risk and fire behavior requires different modeling approaches. So it's not like a one size fits all, that there's one model and limited number of data sets. So it's an information and more a model rich environment. So integrating those and using the right thing at the right time to provide those good bits of information requires a lot of prioritizing. And you know, this is what we mean by the word dynamic, because can we use data dynamically and models dynamically in its actionable period? And as we learn from Neve's forces of data and models, can we actually iterate on things to make those learnings actionable? So we've been working on this area for a while, but like more and more now, the term that is coined over the last decade is digital twins. So what it means in that sense is dynamic data-driven integration of data and models, so we can represent the fire environment in the fire context, so in a virtual setting, in ways that brings the changes and understanding of the unknowns into it as we learn more about those. So that equates to, in operational context, situational awareness, better situational awareness through data. Before a fire, it could be simulation of scenarios and risks and assessing those based on changing fire environment. And after fire, can we actually monitor recovery conditions and other things so that we can keep learning about the effects of the fire as the environment is changing or as new things are happening. So we can update our understanding of the fire environment with the good, bad, and ugly in a way. Yeah. So next, please. So in essence, we notice this is really becoming an area that more and more innovators are interested in, without necessarily getting into the nuances of what this means. And having a community around this as a case study in general for digital twins for the fire environment, I think it will be really useful in the long term to develop rapid solutions together with the right understanding of or grounding in the needs at the operational scale. So enabling this type of research and understanding what operational data-driven operational intelligence means under dynamic, uncertain conditions, and making sure we can be more and more certain through data over time is the goal of this innovation area. And how do we, please stay there for a sec. And then who are the players in this area, right? As I mentioned, digital twin researchers and innovators, fire environment modelers, building blocks for the technology. It's really hard to bring a digital twin together in a scalable and sustainable way. So there's real technological difficulties and foundations that becomes building blocks. So we are also hoping we are going to bring those partners together. And then operational partners and solution providers, of course, is a big part of the approach in general in Wildfire Commons. Next, please. Thanks, Claire. So one of those things in that sense was, as Melissa mentioned, we hold these workshops to identify more of those use-inspired problems and innovation gaps collectively based on this overarching area. So next week we'll have a workshop. We had some calls for interest on those, and now unfortunately it's closed, so we won't be able to accept any more because of limited space to the workshop. But the goal of the workshop is to create two things. One, understand what digital twins exist for fire, but also other related areas or other natural complex environments. So we can identify and prioritize the highest impact use cases. And in that group that we are discussing, we have a large collective of both operationally experienced groups and technical and scientifically experienced contributors and people who's been working on fire tech in a while. And then the second part of it from this group, right, the workshop discussion, we hope that it leads to sort of a blueprint that becomes the backbone of our work, right? Can we have federated, basically, integration or composition of existing solutions into digital twins is a big part of the approach through the FireForge platform in the Wildfire Commons. In general, can we come up with the federated, generalizable digital twin backend framework? So what can FireForge, as Claire and Melissa said, a big part of the approach here is, can we actually have a platform that supports everyone for easier, more reliable and robust deployment of development and deployment of digital twins, as researchers are working on some of those really important depth of what techniques that are needed to actually ensure these digital twins work. And we hope that that we will be able to identify those next week and share with the community. Next, please. And from then on, after that initial workshop, one of the things we will be doing is the data challenge. As Melissa mentioned, we have multiple data challenges in our first case study community. We'd like to have a similar approach and identify one or two data challenges that we can provide to also the community and learners who become talent in this area. But we'll also turn the learnings from the initial workshop and data challenge into a collaboration site that looks like the 4D fuels in the FireForge. So that's also going to be this summer together with the challenge. And at the end of it, we hope to come up with an innovation template that could be really useful for others interested in building digital twins. Next, please. And then this is where I return it back to Claire, I think.
Awesome. Thank you very much, Ilkay and Melissa. So I hope that this helps frame folks around case studies that we've really worked with practitioner communities, active organizations with the fuels, and then working now within digital twins, which it's great to see several folks on this call that are actually going to be participating in the digital twin case study. And I think this is really an opportunity as well for you all that might have an idea that's percolating as a potential case study. We'd love to hear it. This is really a community-driven Wildfire Commons, and being able to capture all of the different use cases and innovation gaps that exist today, where cyber infrastructure can really help support that gap and resolve it. And our target domain continues to be wildfire within the Wildfire Commons. So if you have a clear innovation gap that you would like to share and work with us on, we'd love to receive that. You can contact our team at info@wildfirecommons.org, and we would be happy to set up a time to talk with you and start planning what that case study would look like. And with that, want to express our gratitude for everybody being here. I know that there's a lot of opportunities out there, so we hope that you can collaborate with us on this one as we embed the cyber infrastructure we're supporting to help support others as well.